Hey everyone, and welcome back to video 3 in this series on a shooter RPG made in Godot. This video is largely going to be about the world map and about cameras. And if you haven't covered the code from before, or you just want a fresh starting point, you can pick up from the video 02 code folder. I want to talk about billboarding first. Billboarding is when you have an object that always faces the camera. So in our game, we have that rotation effect, and regardless of how we've rotated this, the trunk of the tree is always on the bottom and the leaves of the tree are always on the top. If we did not billboard our sprites, it would look like this, where the tree could just be anywhere and the goblins would be slanted, and it looks a little bit goofy. So when you have a top-down game like this and it's 2D, you typically want to be billboarding these sprites. So here's what this effect looks like as a video. This is the very smooth camera rotation that we have. Again, it looks maybe a little bit unusual if you're not used to it, but in general, this is the effect we want. So I wanted to talk about it because that's what we have to code. The code for billboarding a single object is very simple. It's just literally what you see on the screen right now. Set the rotation of the object to the rotation of the camera and you're done. But we'll talk about how we incorporate that into our project using signals. The only other thing I want to mention is terminology here. I consider pits to be something that only stop the player, not projectiles. Walls and obstacles stop both the player and projectiles, but walls are part of the tile map, whereas obstacles are just other objects like the archer would be. So they're nodes in our scene, and they can take up as much space as they want to. So this is taking up 6-7 tiles. When you rotate, you only need to billboard the obstacles. The wall actually will look slanted in the game, and that's fine. That's part of the perspective that we want. We'll start by making our world map. So as usual, make a new scene if you haven't already. And at the root of the scene, we're going to put a node 2D that we'll just call world map. Then underneath it, we'll add a tile map. And the tile map, given that our sprite sheet is 32 by 32, we'll need to set the size of the tile map to 32 by 32. And then we need to make a tile set for it. So we'll make a new tile set and then click this. And here's where things get a little bit more complicated. Godot has support for tile sets and tile maps, or else we wouldn't be able to get to this dialog, but it's not the most straightforward. So here we just made a tile set. We can drag our texture onto it, and we now see 3 options at the upper right. Now, all of these are useful. I'm going to cover all of them, but I would urge you not to actually try drawing your map until we've hit the end of this section, because you'll need to undo things if you start making it too soon. Let's start with the easiest one, new single tile. So we click this and we get this option for enabling the snap and showing the grid. And this knows our tile set size because we just set it earlier to 32 by 32. So at this point, we can just start dragging any sort of shape that we want, and that would represent a single tile. So if we click our tile map now, we can see we have our tile that we just made, and it looks like the region that we had. And so I could paint this in. But remember, our tiles are really 32 by 32, so it looks like we're drawing maybe 20, 30 tiles at once right now, but we're not. You can see this overlap here. So I suggest if you're going to use these single tiles in the tile set, that you only set them to a single tile, as you might expect. So we just select a single one here, and then when we go back to our tile map, we can draw them as we would a normal tile. The feature just beside new single tile is new auto tile. And this is really neat. If you've never used this before, this is pretty amazing. The way that it works is you choose a region of tiles and then you fill in a bit mask where each of the paths would be. And this will make more sense depending on your sprite sheet that you have. So here it's a path. And then when we go to draw it, watch what happens here. So I can draw these arbitrary shapes with just this single tile that I have. And since it's an auto tile, it'll fill in these borders for me. Now you'll notice that they're a little bit of a glitch over here, for example, and this is a shortcoming of the sprite sheet and not of the feature of auto tiles. So the way that this works is that we set bit masks on quadrants, which means that there are 16 possibilities from none of them being filled to all of them being filled. So for example, we have a bottom side, a top side, and a right side. The left side is actually in this sprite sheet, but it's way over here. And then any of the other combinations, like having an L shape in any of the directions, we just don't have. So the more tiles you have to fuel your auto tile, the better it'll look, and the more time it'll save you because you won't spend time dragging individual shapes where they need to be. The final feature that you have over here is new atlas. And just like with an auto tile, you're going to drag a region. So let's get just this region here. And now we can draw with this as though it's our palette. So I'll expand this, and if we want some of this tile, we can draw that. We can draw some of this tile. We can draw some of this tile. Auto tile and atlases are the two main features I would use here. I don't find single tile all that helpful given that we have an atlas, and that's really just many single tiles. So I suggest using those features. Godot has several tools and shortcuts that will make the actual drawing process easier. And they're all up here, and you can hover over them to see their shortcuts. So I'll just show them off without saying what the shortcuts are, since you can see what they are in your own system. But we can draw, we can delete, we can make a line of tiles, we can make a rectangle of tiles, we can flood fill a space, we can select a region that we want to draw multiple times somewhere else. Let's say you had a house or something that you want to draw repeatedly. And we have the picker tool for selecting tiles without having to find them from your atlas over here. It's also good to know that there aren't really any limits here. So if I drag down to the bottom, you can see it just stops, but that's because I just haven't drawn anything down here. If I do, now I can draw even lower, and then even lower, and then even lower. So as you either draw or just zoom out, you can draw very large maps, and Godot will handle this in a performant way. This tool is definitely confusing. Let's say you made a new single tile here and you made a new atlas around it, and then you think, okay, I'm just gonna click this tile now, and maybe you think you can modify it. Doesn't really work that way. So here's what I learned from my usage of it, and I suggest sticking to these guidelines. Anytime you make any new tile, name it immediately. So here we might just call this atlas, or we might call it tiles or something like that. Then we might make a new single tile, and let's say we name this one green sludge. At that point, now that you have the names, you can click this I button, which is beneath where my head is, and now the tile names will show up right there on the tile sheet. So we can see that our atlas was here and our green sludge was over here. The other thing is, instead of ever clicking on the tile sheet to select them, I would always just use the arrows. That way I can see what's selected. Collision is done in the tile map and not in the tile set. So what that means is that you have these collision layers and masks, which we will cover later in this video, but you're setting them for the entire tile map. So earlier I mentioned that we want water to be pits and these stone things to be walls. We can't actually do that. We can't choose one of these and then say for its collision that it should be in a particular mask. We can just say that this is the collider for this tile. There are two other things that have bitten me in the past here. One is that the collision button just sometimes disappears, and when that happens, I just reload the editor completely. I don't know what causes that, it's just a bug. And two is that you can only create a collision rectangle for the tile you have selected in an atlas. So here I have this selected, and I might try dragging a rectangle around this one, but I can't actually do that unless I select it first and then draw a rectangle. So just keep that in mind when you're going to be making collision for any of these, because like I said, it's confusing. Now that we know about some of the pitfalls, let's just rewind back to before we even had a tile map. And we'll add it again, we'll set the size, and we'll make a new tile set, click it, and drag our spreadsheet onto it. Now, for what you do, I would suggest finding tiles that you actually like here. I'm not going to make the final map right now, so I'll just select this over 2. And then as I mentioned, it's a really good idea to edit the name of this. So you might say desert biome or lava tiles. So I'll just call these tiles for right now. And now that I have them, let's draw in a rectangle of those and then some of these walls. I haven't actually made them walls yet though. In order to edit their collision, I'll zoom in a bit here. We need to click the arrow to select our tiles, collision, select the tile that you want to modify collision for, choose the tool, so the square tool, and then I will draw a square on it. And that's it. So now let's test this out. I'm going to instantiate an archer into this scene so that we don't even need to go through the character select screen, and then hit the play scene button. It's going to ask if I want to save this. I do. We're going to save it as world map. And we can see that we have collision with the different tiles over here. Remember, all tiles on the tile map will have the same collision if you set it. So we're going to call this walls, and then we're going to make a new tile map and call this one pits. And this is where we're going to do the same general process, except this time around, we're only going to draw water tiles on it. So I might even just make new single tile over here and call this water and set its collision to the whole tile. And then when we go over to our tile map, now we can draw in, I forgot to modify the cell size. It's pretty important. So now we can draw in water tiles. The only thing to keep in mind is that these are two completely separate tile maps. So for example, if I drew something like this and I tried running the fill tool, it won't actually fill this whole space. It thinks that the tile map's boundary is just this top part because that's all I've drawn in so far. So that's why this isn't working how you might expect. And likewise, if I were to hide this layer, it's not that I overwrote any of the tiles underneath it. They're two completely separate tile maps. If we run the scene, we can see that our player is properly colliding with walls, which was already the case, but they're also properly colliding with water. However, the pits don't know that they're pits right now. All of them just know that there's collision on them. So how do we differentiate between them? Well, if I move my head a little bit, you can see behind it that there's layer and mask over here, and that's what we'll use. Layers and masks, from a conceptual standpoint, aren't too complex, but they can sometimes be easy to mess up. So let's talk about them. And if it doesn't make sense during this, don't worry, because we'll get back to the editor and we'll talk about it more there. A layer is what an object is considered, and a mask is what that object considers. So let's look at an example. Our archer is a player, so it would be in the player layer. And it considers to collide with the world, the pits, enemies, enemy projectile, and of course you can have as many layers or masks as you have bits for, which I believe is 16 or 32. You probably won't need them all. Another example, we have a dragon. That would be an enemy, so we put it in the enemy layer, and that maybe we say does not collide with the world or with pits. Maybe it can move smoothly over those because it can fly, and it only collides with the player and projectiles. The way that Godot itself defines these is that if object A has a mask that is object B's layer or vice versa, then there will be a collision that happens. So again, if that doesn't totally make sense, we'll get to this in the editor and we'll try it out. Let's try to make sense of this back in Godot by considering the defaults that are assigned. If we look at our archer scene, we have a layer and mask of that first bit being set. If we go look at our world map, we have the exact same thing. And we know that this results in collisions because we just ran this already. But let's say we use the remote view here and we examine what happens when we turn off the collision layer. So now the world is not considered to be in any layer. What do you think will happen? Well, the player still does collide with the world. And the reason why is because of this quote from the slides. A contact is detected if object A is in any of the layers that object B scans or vice versa. And what's happening is that the walls aren't considered to be in any layer, but they're still scanning the one that the player is in. So it's not until we turn this off that we can move through this. Likewise, if we were to turn this back on, we could turn this off on the player, and I could also move through these. So by doing this, we can assign a layer to the water, assign a layer to the player, to the walls, to projectiles, etc., and then control their layers and masks to allow collisions between them. It's very hard to work with these layers and masks when they're literally just called layer 1, layer 2, layer 3. So if you go to project settings and then type in physics, you'll find all the different layer names in here, and you can just assign them to whatever you want. So I have all of them typed out. If you want to match what I'm doing, you can set these up now. We are setting up all of the layers, even though we're not using all of the layers yet. So we're not adding projectiles in this video, but we're still going to make the layers for them. Now, when you hover over them, you'll actually see that it still says layer 1 and layer 2, and that's due to a bug in Godot. I think the way you fix this is by reopening the scene. And yeah, so that worked for me. If that doesn't work for you, just try reopening the whole editor. One more thing, the reason why we differentiate between the player and their projectiles, and same thing with the enemy and their projectiles, is because imagine that we have, let's say, a pressure plate in the game. And when you step on it as a player, it would fall into a pit. If our projectiles are classified as a player, then even shooting an arrow over this pressure plate will trigger it because the game doesn't know what you're representing. All it knows is that layer 3's bit is on and layer 5's bit is off, or vice versa. With our layer names set, we can now categorize all of the different entities in our game. So what you'll do here is you will go into each different scene and you'll categorize them. And unfortunately, you have to hover over each one unless you remember where the bits are. So the player is going to have this third bit on, which is the player layer. And then for mask, it's going to collide with walls, pits, enemies, and enemy projectiles. And so you would do this with everything that you have here. I would customize the same thing for walls. I would go into its collision. I would modify that it's set as walls, and then it's colliding with the player, enemy projectiles, and player projectiles, etc. You would do this for all the different scenes. Just because you're doing it for every scene doesn't mean you have to do it through every scene in the UI. You can also do it through scripts. And since we have an archer, a mage, a warrior, you might have made 7 other classes, it makes a little bit more sense to do it through a script. So let's go modify the player's script. We don't already have a ready function. Remember that ready is called automatically by Godot when this node and all of its children have entered the scene tree. And so now we have code that sets the collision bits directly through the script. Now that it's there, we can save this script and we can unset the collision that we set earlier directly on the player itself. So we can actually just revert both of these things and then uncheck the layer and the mask. So now this is empty, but because we have that script, when I run this, the correct flags are going to get set. So we're still colliding with the world and with the pits that we have here, even though the archer scene itself does not have a layer or a mask because we added it through code. I like all but one part of this solution, and the part that I don't like is that this code is incredibly ugly. We have 12 lines and 1 blank line, so we have 13 lines here to set just 2 pieces of information. What's more is that it's incredibly hard to tell through the code what do these numbers represent. And we know from our project setting what the order is, but do you want to look through that dialogue every single time? So let's combine 2 things that we learned about earlier. One is setting constants, and we can make an enumeration here, physics masks. The only thing to keep in mind is that this has to match exactly the order that you have in this dialogue, because remember that enumerations are really just numbers underneath. So this is going to be 0, this is going to be 1, this is going to be 2, and these numbers are also 0, 1, 2, and so on. So those have to match. The second thing is that we need to make a new auto-loaded script called util.gd. We're going to do this the same way that we did this with constants, which is to right-click scripts, go to new script, type util. Then we need it to be auto-loaded, so we go to the project settings, go to auto-load, open up your util file, remember to click add, and all that did is we made a new script, and now it's going to always be in the scene tree, so it's usable. Now let's give it the code that it needs. So we're going to wipe out the code that it had and put this in. And I've heavily commented this, so I'm just going to quickly explain what this does. We have those enumeration values, and remember that those are 0, 1, 2, etc. And we need them to be in a bit mask, which are powers of 2. So 2 to the 0, 2 to the 1, 2 to the 2. So all we need to do is call this function, and it'll convert the enumeration values into the collision layer and mask, bit mask values that we need. Calling the function should replace what we had in player controller and the ready function. So here's our ugly function, here's our clean function, and we're passing in that array of enumeration values, just like I said, but more importantly, we can now read what these are. So instead of wondering what is 4 or 5 or 6, we can just see world walls, world pits, enemy, enemy projectile. To test this out, there's a kind of cool technique we can do here. So we can go to the world map and we can instantiate in all of our different characters. So you just click this link button and select them all and click open. And then I drag them to different positions. Then when we run the scene, we'll be controlling everything all at once. And we can see that they're all colliding here. And what's nice about that is since they all have the player controller script, and since that's what's setting the collision mask in the ready function, we don't need to go through and test individual scenes, and we don't need to go make modifications to those individual scenes because they share a script. We have walls, we have pits, but we don't have trees, the obstacles that I wanted. So let's add in a new node here, and this is going to be a static body 2D. Remember, it is static because it's a tree, it doesn't move, and it's a body because it needs to be able to collide with things. At this point, you should be able to fill in the rest on your own, but let's go through it anyway. So we're going to add a sprite underneath. We're going to give the sprite our texture that we want. So let's drag the texture over. We're going to enable the region and click over here to texture region. We already have grid snap enabled, so we just need to find our tree. Let's go with this one. And then we need to add a collision shape. And our collision shape that matches this is a circle pretty well, at least. We drag this down to the base of the tree because that's all we want to collide with. And we got a good approximation there. I would also rename this to tree, and then we will set our collision layer. So this is considered to be part of the world. For all intents and purposes, it is a wall. And what it would collide with here is going to be the player and projectiles. If you did not set the mask, that's okay as long as the player and the projectiles are setting their mask of being the world layer. Remember that whole object A and object B and vice versa quote that I still have in Notepad here. That's what makes it so that we would only need to set this on actually one of the objects. We're doing this just for thoroughness. Save your tree scene, and now we can go instantiate it into the world. So let's add just a regular node, and we'll call this obstacles. and we can just start instantiating trees into here. So let's add one, and then we'll just duplicate it a few times by either right-clicking and going to duplicate or pressing Control D. So here are all of our trees. Let's put them in various parts of the world. I hope your map looks better than this. And then we can start making some modifications now that we've got them here. Let's modify the transform of this one. So now we have a very large tree. And then with this second one, let's try something a little different. We're going to right click and we'll go down to editable children. And this expands what we have in our tree scene over here. So we had a sprite and a collision shape. So now we can modify them directly from here. And one of the cool things that we can do with the sprite is modify its modulate. So let's change this to reddish, let's say, or get a green tree or any of these sorts of things. So you can change now however you want this to look. You can update its transform, you can update its scale. The one thing you should be careful with editable children is that you don't end up just moving the sprite around. So you see how I detached the collision from the sprite, and actually there's also a tree node hovering there too. To prevent that, you can again use this button up here. Make sure that objects children are not selectable. So I click this, and now this tree is essentially locked. And so if I try moving the sprite, I'm actually moving the whole tree. And we can test this out. Just like before, since we instantiated trees, I've got like 6 different players. And yeah, you can see that there's collision. A little bit hard to tell because of how many characters are moving all at once. Let's cut down on the number of characters so I can show you a tiny problem that we have here. So we'll move this tree up to the top and we'll run our scene. We see our character, it's colliding with the tree. Okay, that's good. But then we move underneath the tree, we can't see our character, and we still can't see it until it exits the shadow. That's a little bit strange, but this is more of a sprite sheet issue. And there are a couple of things that I'd say here. One is that you might want to just go into your sprite and edit it. So open it up in an image editing program and delete the shadow from it. And then you could later add that in as another sprite or through code. In our case, I'm not going to do that. What we'll do is we'll just make sure that the maximum tree size is about a scale of 3, because then it's less noticeable. And we'll also go into our tree scene over here and we'll give it a z-index of 2. That way it'll always show above the player, regardless of where it is in the world, so that we'll always go underneath the shadow. I accidentally opened the wrong scene there. Let me open the right one. Yeah, so now it's a little less obvious. It's still happening, but it's not as apparent. You should now know enough where you won't feel remiss if you've drawn a pretty map because you won't have to delete it. So here are a bunch of tips. I suggest making a relatively large map. I made one that's 100 by 100. I walled mine in with water. You can read the rest of this slide. Here's the map that I ended up making. I am by no means a level editor or a map designer, so this looks pretty terrible, but it works. It's just the map in the end. You can make this look as good or as bad as you want. If you haven't already by now, remove the players from the world. There's no need to have them there. Your scene, when you open it, should just be a map. In fact, I can't control anything because there's no player on here, and there's no script on the map, so it's just a static scene. Then we're going to go into the gameplay scene, and we're going to instantiate our world. So we will put the world map in, and now when you run the whole game, so if I press F5, which is not just playing the scene, we will be able to put our character into the world. If you were to maximize the window right now, you would just see more of the map. You can see that these brown tiles are now visible, whereas before they weren't. If we want to change that functionality, we can go to project settings, and then in general, search for display. And in window, we will find all the way at the bottom, different stretch properties. So we'll set stretch to 2D and aspect to keep. And once we do that and run our game, now when we maximize it, we see everything take up the full screen. You also see this massive tear in the middle of the world. And once we get to camera movement, actually depending on the size that you make this window, you'll see tears at different stages. That tearing that you see is likely happening because we're trying to render to subpixel coordinates. And it has to do with how we're stretching this and scaling it and exactly what's going on in the graphics card. Thankfully, Godot has a way of fixing this. If you search for snap, you will find it in rendering quality. So there's use pixel snap. And what this is going to do is draw only to integral coordinates. So now when we run our game, we should not see any more tearing. So if I resize this, it's looking pretty good. At some point, you may start wondering about the frame rate that your game is running at. Godot makes this very easy to find. You go to debugger and then click monitors, and it's right there at the top. FPS is frames per second, so we're running at 60 FPS here. That's pretty good. That's the refresh rate of my monitor. You might have a more expensive monitor and you might be up to, say, 240 Hertz. So if you want to see what your game would run at, if you weren't limiting it to your monitor's refresh rate, you could turn off VSync in the settings. And here I just search for VSync in the project settings. I turn it off, I click save and restart. This does require an editor restart, but then we can launch our game again. And I'll actually go to the world view first here, and let's look at our frame rate. It is about 1100 frames per second. Remember, this is with a gigantic world existing in the background, but it's not drawing everything all at once, and that's something that Godot handles for us. So you can focus more on just making your game. We have our player and our world map, but when we move off the screen, we're just off the screen. There's nothing there to look at us or to move the camera. And a camera in Godot is the same as any other node. You can just add a camera 2D, and then you can set it as the current camera over on the right side. And now when I launch the game, we will see the camera pointing where it looks like it's pointing. And you can actually see this faint blue box. It's a little bit hard to see because of the water. If we were to move the camera around, and let me put this side by side, we can go to remote and look at where our camera was just added. And we can drag this around. And you can see it doesn't update in real time. I have to let go of the mouse, so it's not as I'm dragging this. But this lets us see different views into our world. So our goal is going to be to make this move with our player. Remember that we have 3 players, Archer, Mage, and Warrior, but we have one script for all of them. So I'm going to delete this camera from gameplay and add it through the player controller. Let's go add as a member variable a camera here, camera 2D, and then in init we'll paste in some code that will construct the camera for us. Let's look at what this is doing. We're making a camera, we're naming it. Then we're changing the zoom level, and this is mostly just for my eyesight. The tiles that we're drawing are 32 by 32, so they're pretty small. So we zoom in a little bit, and that way we can see more detailed tiles, but we'll see fewer tiles, of course. So this does have an impact on the game. If you really want to be able to see very far away, you could have an advantage because you'll see what enemies are over there. We set it to current just like we did when we made the camera manually. That means that it's going to be the camera we're rendering through. And we set it to rotating because eventually we're going to want to rotate the world. And what we're actually doing is rotating the camera in that world. And then we add it to our scene. This is going to be added as a child of player because add child is called on this player controller that we have, which means it will automatically move with our player because that's part of the scene tree that we have. And we learn this just like how the sprite is moving as part of the kinematic body here. So that's it. We just got camera controls practically for free. Just like every other kind of script or node, I do suggest looking through camera 2D here and seeing what else they have to offer. So for example, they have this smoothing enabled. Let's just set that to true and see what it does. So I'll save this and we will launch the game again. And now do you notice a difference? It might be subtle because you're not directly controlling the game, but you can see that the camera is slowly moving toward the player. Now, this would be incredibly nauseating with what we're about to do, which is rotating the camera. So I don't like this for this game, but feel free to look through these other options that you see and maybe you find something you like. As I just mentioned, we want to be able to rotate the camera. So let's go into player controller and we'll add a few things to different parts of the file. So here are some variables that we have. This is going to indicate whether or not we're rotating the camera based on the input that we got, and this is the speed at which we're rotating the camera. Then in our unhandled input function, we are going to add this code. So we're saying at the beginning, just like how we're making a new velocity, we're saying that we haven't actually moved the camera yet. And it's not until we press something that we're going to move. And we don't have rotate right and rotate left, so we'll go add those. Input map, rotate right, rotate left. And I want right to be on the E key and left to be on the Q key. Good. And then at the bottom of our file, we are going to change our physics process. I'll actually paste this one next to it. So originally we had move and slide. Now we're also going to be modifying the camera rotation. And now that we're using delta, we got rid of the underscore to indicate that we weren't using it. And that is our code. Let's look at it. We are adding to the rotation of the player, which is a parent of the camera, a value multiplied by the speed. That value is either 0, 1, or -1 based on whether we're pressing a key. The speed is just the number 2 for right now. That's at the top of our file. And then delta is the amount of time that's passed in fractions of a second. So basically we're going to be either increasing this angle or decreasing this angle. And because all the angles are following a circle, if we just keep infinitely increasing it, it's just going to go around this circle essentially. So if this were the number 1 million, it's not really that different from it being the number 40, let's say. So let us try this out. What do you think will happen when I press E, which is rotate right? This player is what's rotating and the camera is a child of it. So when I press this, what we're seeing is that the player is remaining at the same orientation the entire time. The reason why is because if you remember back to our billboarding formula of object.rotation equals camera.rotation, that's always true for this because there's the sprite and then there's the camera alongside it and they're being controlled by the same rotation value. And then the rest of the world, this is actually very hard to control now because the keys are not moving in the directions I expect. The rest of the world is not looking how it should. We're not actually doing any billboarding yet. I just mentioned how movement is unusual. It's because when we're rotated, up is not going to move from my characters up. It's going to move to north in the game. And that's because I never rotated my velocity. So I'm going to press down right now and we're moving south in the game. In order to move relative to my character, this velocity just needs to be rotated. So we'll rotate it by rotation. And then when we rerun the game, now when I rotate, I can still always move to the players up. So this lets me move in a smooth circle, whereas before I would always have just moved straight north. There's one other thing I want to change here, other than that I accidentally left camera smoothing on. The player is always in the center of the screen. So if I delete this line and we rerun this, that was camera smoothing, they're always stuck there right in the center. And for gameplay reasons, I want the camera to be offset from the player so that we can see farther in a particular direction than the other directions. This will let you evade enemies or move away differently. So when I make the camera's position, I'm just going to offset it from the sprite, and that's all we have to do. Now the player is lower in the screen relative to everything else, and we can see farther wherever the player is facing. So this cone of vision is now farther going sort of southeast in the world here. The other problem that I pointed out is that we're not billboarding the trees so they can just look upside down completely. Do you remember signals? How I said that the player can basically shout to the world that, hey, I've rotated by 14 degrees. And then whoever wants to can listen. Well, we can add that in over here. So we say that there's a signal and it's going to be called rotated. Typically signals are in past tense. And when we call the signal, we're going to call it with our current rotation. And then we will put this into our physics process function, which is what Godot is going to call every physics tick, that if we did actually change the camera to emit that signal. Now, who should listen to this signal? Well, it's got to be something with a script, and it could really be anything that is at the tree level or higher. And by tree here, I mean the actual scene tree. So this kind of tree, not the scene tree. It's very confusing. So we could put a script on this tree. We could put a script on the parent of tree, which is technically obstacles. We could put it on world map. We could put it on gameplay, or we could put it on main. So I don't think it makes sense for a tree to have a script at all because it's not doing anything else. And I don't think it really makes sense for world map to have one right now. So I'm going to put it into gameplay. In gameplay, we will add this to our player. So here we're connecting to the rotated signal, and we're going to call our onRotated function, which does not exist yet. We will add that in as well. And so here what we're saying is when we rotate, we want to update all of the obstacles. So how do we do that? Well, let's look at our scene tree. We have gameplay followed by world map. And then if we click this little clip symbol, we'll go into world map. We have obstacles, and then we have all of our trees. So we learned about that $sign syntax earlier. We can go back to our gameplay script, and in update all obstacles, we can put this code. So what this is doing is it's saying go to our world map, then go to obstacles, and then get all of the children of that. Then for every child, we are going to set its rotation. So let's test this out. So we rotate, and now you can see that all of the trees are getting rotated to the same thing that the player had. And the player's rotation is the same as the camera. And whenever anything matches the camera's rotation, it's billboarded. So now all of them are facing up no matter how we are rotating this. And you may be wondering, with the player, the camera is a child of it, and all we had to do was set the player's rotation, and then the camera got rotated. So why are we getting all the children of obstacles if we could just set the rotation on obstacles itself? And so let's try it. We don't even need to write code for this. We can just go into our scene, and we need to first change obstacles to a node 2D because node actually doesn't even have a rotation. And then let's just change the rotation here and see what happens. And so before I do this, what do you think will happen? Do you think all the trees will rotate just as they did before? Because this is a trick question. They will not do that. You can see that they actually rotate around the origin. And this is exactly why we can't use this technique. At any point, rotation is going to be around the origin of what's rotating. And since the trees themselves aren't rotating, it's their parent that is, then they're going to rotate around their parent's origin. So this is why we can't do this method and why we'll just change this back to a regular node and rely on our code that exists in order to rotate individual trees like we already saw. That's it for this video. I think the most important takeaway from this is about collision layers and masks, because that is going to be part of probably almost any game that you make. You're going to want to have something interact with something else, and you'll typically do that through collision layers and masks. So thanks for watching. Hope you learned something, and all the code from this video is going to be in the video 3 folder.